Okay, we're going to look at how to determine, we're going to look at the rules for negative exponents and zero exponents. We're going to use it based off a pattern. So what we're going to do is we're going to fill in this table and then look for a pattern. We start off filling in the table with 5 to the 5th power, and we can just use our calculator. And we fill in all of those blanks. Now, as we are filling out the pattern, now we're looking for the actual pattern. On the left, it's easy to see the pattern 5, 4, 3, 2, 1. So the next problem is obviously going to be 5 to the 0, and that's what we're going to find next. Now, to find that, what we're going to do is look for the pattern here. A lot of you might recognize the pattern as it goes up as being multiplication. 5 times 5, 25 times 5, 125 times 5, and 625 times 5. But we're actually going down, so that's going to be the opposite order. It's going to be division. So as you can see, we're going to divide that by 5. 3,125 divided by 5 gives you 625. And then it happens again, and again, and again. Okay? So clearly, if we continue this pattern and divide by 5, 5 divided by 5 here should fill in that blank for us, and it does. And now we can see that 5 to the 0 power is 1, and that leads us to what we know in our toolkit, that any number to the 0 power equals 1. We can run through this again if you need to, but that's just kind of the why. Okay, I can change these numbers here to any other number in the world and do this same table, and I will get the same result every time. Any number to the 0 power is 1. Okay, in our toolkit, we already have that rule written down, but off to the side, we've got 4 examples here that we're going to write down for our 0 power rule. The first one is as straightforward as it gets. Any number to the 0 power is 1, so 4 to the 0 power is 1. It's that simple. Use your calculator to check if you need to. The second thing I want you to notice is the difference between these two problems here. Notice that one of them has a 0 on the outside of parentheses, and the other one has a 0, no parentheses, but a 0 only with the x. And that's the biggest thing we want to look at. So we'll start with this first one. Notice on this first one that the base of this exponent is actually the parentheses. So both the 3 and the x are the base of this exponent. Well, if I just consider my problem like this, it really doesn't matter what's inside those parentheses, because anything in these parentheses raised to that 0 power is going to give us a 1. And it's pretty much that simple. Now, on this second problem, what number is the base of the exponent 0? Well, that number is just the x. X is the only thing being raised to the 0 power. So I can change that to a 1, but that still leaves me with a 3. And of course, as you see, you can simplify that, and 3 times 1 is 3. So the answer to this second one is 3. So take a minute to run through those two examples again and notice the difference between these two. Alright, on this last example, we've got a multiplication problem. Anytime that we're multiplying with powers, we try to find powers that have the same base, and then we add the exponents. So that's based off of our power rule. Based off of our power rule from the other day. So we end up with x to the 0, y to the 7th. Well, of course, this x to the 0 is just a 1. So I've got 1 times y to the 7th, which gives us plain old y to the 7th. Okay, we're going to use the same exact table and continue our pattern. This is the table we used from before. We're going to continue that pattern to find out what negative exponents do. So I already have most of the table filled out, and remember the pattern was to divide by 5. So I'm going to divide by 5. Now that gives me a 0.2, which I changed to a fraction, is 1/5. It's easier to see the pattern with the 1/5. If I divide by 5 again, I get 1 over 25. If I divide by 5 again, it's 1 over 125, and I hope you can see the pattern now, 125. And go ahead and take a guess as to the next one. It's going to be 1 over 625. Okay? And what we're trying to find is these patterns. Do you notice how these match up? And what is the relationship between these called? It's called reciprocals. So that's just something to kind of look for. So when we use negative exponents, we basically, the answer to a negative exponent is the same thing as the answer to the same positive exponent if you take the reciprocal of it. So again, the answer to a negative exponent is the reciprocal of the same positive exponent. Now, just to clarify that, I could rewrite 625. Oops, I started with 5. I could rewrite 5 as being 5 to the first power. And I could rewrite 25 as 5 to the second power. And that's what I did here. And so forth and so on. Oops. So all I'm trying to do is show with this is that 5 to the fourth is the same thing as 1 over 5 to the fourth. 5 to the third, negative third, is the same thing as 1 over 5 to the third. 5 to the negative 2 is the same as 1 over 5 to the 2. Notice the exponent becomes positive. 5 to the negative 1 is the same as 1 over 5 to the 1. And that's our exponent rule. Now in our toolkit we have these directions. And here's what it means to do. Alright. 7 to the negative 1/3 is going to be 1 over 7 to the third. Notice I do the reciprocal of 7, which is 1/7. The negative 3 exponent becomes a positive 3 exponent. And then of course I need to simplify that. And 7 to the third is 343. Over here, x to the negative fourth, I'm going to flip that for the reciprocal. The reciprocal of x to the fourth is 1 over x to the fourth. Notice that here's the reciprocal, and the negative 4 exponent becomes a positive 4 exponent. That's important because I'm not allowed to have negative exponents in my simplified expressions. Notice the similarities between these two problems. Okay, if I rewrite this first one a little bit more clearly, you can see that it's where the division bar is. It's very clear to see that this negative 6 belongs with the A and only with the A. It really doesn't touch the 5 at all and has nothing to do with the 5. Okay, so all I'm going to do is the reciprocal of A to the negative 6th. The 5 is still the 5. How do I keep 5 in the numerator? 5's in the numerator here. Look, it stays in the numerator here. Times. Now I flipped this. Notice that it was in the denominator. Now it becomes in the numerator. The exponent was negative, but I switched it to positive when I did the reciprocal. And you can see that that becomes my answer, 5a to the 6th. This other example is in parentheses. So what I want to pay attention to is what is being raised to the negative 2 power? Everything is being raised to the negative 2 power. So I'm going to do the reciprocal of everything in the parentheses. You see the reciprocal of everything in the parentheses. Now, that's still going to be raised to this power, but since I did the reciprocal, I can change that to positive. And now I'm allowed to follow my quotient and power rules, and I can multiply those two. X squared to the second power is x to the fourth, and 4 to the second power is 16. I encourage you to review this as often as you need and check out your work tonight.